When TDD was new, I remember there being debates about whether it was best to test first or to test after. That is, should we write the test first before we write the code, or write tests only once the code is done? I think that this was always based on a misunderstanding, if I'm honest. It was always write the test first. I haven't heard anyone debate this for a long time now, but I still see lots of people who assume that writing tests after the code is done is a valid form of test-driven development. It's not. We can't be test-driven unless we're driving the code from tests. So the tests must come first. But why does that really matter? And what are the problems with writing tests once the code has been written? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. I think that what most people seemingly understand when they first hear about test-driven development is that it's all about having lots of tests. And it turns out that that seriously misses the whole point, really. This is understandable, though. If you look at where test-driven development teams end up, they end up with lots of tests. But that's never really the goal. That's a side effect. It's a very good side effect, but it isn't the goal that we're aiming to achieve. The goal of test-driven development is not perfectly tested software. It's very good, very high-quality software. And that matters for a variety of reasons, but not least because it allows us to build software faster as well as better. So lots of tests is certainly an outcome from test-driven development, and a positive outcome. But whether this helps us to achieve our goal or not is really a very different question. And this is where there is a profound distinction between tests written before the code and tests written afterwards. Having lots of the wrong kind of tests doesn't really help much, or at least doesn't help enough. Let's start with the positives. Well-tested code is generally a good thing, nearly always better than poorly tested code. So a project with lots of automated tests generally has a better chance of working than a project with few or no automated tests. But the nature of those tests matters a lot. And this is why when the tests are written in the development process matters a lot too. Let me pause there for a moment and thank our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Tricentis, Transfic, Sleuth and IcePanel. All of these companies offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and in software engineering, please do take a look at their links in the description below and support them for supporting us. Thank you. In the early 2000s, I worked for a consultancy called ThoughtWorks. We were largely built on applying extreme programming, often in larger scale, more complex projects, and we were doing lots of interesting things, innovating quite a lot and experimenting with lots of new ideas at the time. This is where the ideas for continuous delivery and behavior-driven development started, for example. Test-driven development was core to pretty much all of our teams at that time, and we started to see some patterns in projects that took automated testing seriously. Teams that wrote unit tests after the code had been written seemed to follow a reasonably common profile. They produced good systems with comparatively fewer bugs because the tests made sure of that. But over time, these systems got harder and harder to work on. The reasons for this are actually pretty clear with the benefit of hindsight. Let's think about why it is that when we write the tests matters at all. If we do the conventional thing and write some code and then write tests for it afterwards, that means that the code was written first, obviously, and so inevitably is less easy to test. This is inevitable because at the time when we're writing the code, even if we are very diligent and are thinking very carefully about how to write that code in a way to make it testable, this is an untried guess because we aren't actually trying out our testability choices as we go. We'll also have a lot of other things on our minds during this time, and since the issue of testability is only one of them, inevitably we won't get our full attention. If we write our tests before we write the code though, we're only thinking about designing the code in a way that makes it nice and easy to test, which also means designing it in a way that makes it easy to use. Another of these very good side effects from test-driven development. The result of this is that the code generated via TDD is differently shaped to code that is not. This matters for reasons that go well beyond testing, but we'll get to that a bit later. So when practicing after the code unit testing, we don't get the pressure on us to create more testable code that TDD provides. So our code will be less testable as a result. So now, when we start writing tests, once the code already exists, this is going to be a bit more difficult because we don't have access to the information that we'd really like to have to check in our test. And also the code is more difficult to set up, to get it into the state that we need it to be in for the test to work. I've started to think of one of the impacts that TDD has on the design of our systems as encouraging us to expose what I think of as measurement points in our system, places in the design that expose what's going on in the code. Because we're designing the external view of our code when we write a test, we can do this without compromising the degree to which our code exposes or hides information, and so without increasing the coupling between the test and the code. The converse of this is what happens when we write tests after the code. Because we're not forced to design these measurement points, we have to either not measure the things that we'd really like to, so our test is worse, or look for side effects and try to infer what's going on, so our test is more complicated, or access information that really should be hidden as part of the internal workings of the code. And so we end up with tests that are way too tightly coupled to the code itself. And all of these outcomes are extremely common in test after projects. Testing is not as thorough, so leaves gaps where bugs can slip through. You don't get as many bugs in test after projects as you get in manual testing only projects or no testing at all projects, but you get more bugs than in TDD projects. And tests written after the code are nearly always bigger, more complex, flakier and slower to run because they are more complex than pure TDD tests. They are more complex for two main reasons. First, setup's a lot more complicated, as I mentioned, and then because of this, we're lured into including more stuff in the scope of a single test. Setup is complex because you can't fake things easily because you didn't design them to be faked in the first place, and because there's nothing to stop you making setup more complex. In test-driven development, if the test is hard to set up, it means our design is bad, so we change it. The lure to bigger tests is because it took us so much pain to get to this point that we may as well assert a lot of things now that we're here to make the journey worthwhile. Often these things that people thought of as unit tests aren't really unit tests at all by this point. They're at best reasonably complex integration tests, and at worst they require you to start up the whole system, or a significant chunk of it at least, just for a simple test. Here is a test from a well-known open source project. This test runs a copy of the application, configures it, then inspects the DOM in a web browser for that web page in order to be able to extract the text of an error message and then validate it. Just think of all of the things that could go wrong that could stop this test from running in the first place or then passing. Things that have nothing at all to do with what's being asserted here. What if the operating system was the wrong version for this version of the application? What if the application wasn't in the right place on the disk? What if the locale of the operating system meant that the application was reporting in French instead of English? None of these failures, and probably hundreds more, have anything at all to do with what's being asserted here. These are side effects of how this test was written, rather than what this test is testing. So this test is hugely contextual and coupled accidentally to all sorts of things that shouldn't matter at all. Take another look. There is no way on earth that anybody in their right minds would choose to write a test like this before the code existed. This test was obviously written after the code, at which point someone thought, oh, maybe we should test for an error message. If we were practicing genuine test-driven development, it would be completely the other way around. What do we really want the code to do if it's misconfigured? And we'd probably end up with something a bit more like this. A simpler, faster, clearer, and something that acts as a specification of what should happen without describing how it happens. Our implementation is also simpler and more flexible as a result, more focused. It doesn't execute as much stuff as the first test, but that's a very good thing. This is a unit test, and unit tests should be small, narrowly scoped and simple, and ideally have a single reason to fail. Tests like this first bad example are extremely common in my experience, but only in teams that write tests after the code. Now this is a problem because a lot of people confuse this kind of testing with test-driven development, as I said at the start. I've learned that I can't simply ask people, do you practice test-driven development? Because if they say yes, I still can't tell whether they do or not. If I really want to know, I have to follow that up with something like, do you write the tests first? Or something similar. This matters because, at least to my ears, all of the common arguments against test-driven development are actually arguments against this weaker test-after form of unit testing. Now, as I said, code that's tested is better than code that isn't. But this test-after form of testing is really a local optimization and gets us to the wrong place. You've climbed a small hill that puts you above the depths of the valley with no testing. But now you have to descend back into those valleys and climb up the real mountain to get where you're aiming to be in the first place, test-driven development. If you'd like to try some true test-driven development for yourself, check out my free TDD tutorial. There's a link to that in the description below. Now, it does take some skill in design to get to the real advantages of test-driven development. But one of the reasons that I think test-driven development is so important is that it encourages you to do things that improve your design skills. The key step here, the idea that I think elevates test-driven development above merely unit testing, is the focus on testing behavior rather than implementation. This was described in Kent Beck's original writings on TDD, but it often gets ignored. To elevate the focus was also one of the original ideas behind behavior-driven development. Our aim was to try and refocus TDD onto the stuff that really matters, specifying the behavior that we want. I think that looking at the construction of a test case as an act of design, where my goal is to clearly specify what I would like my code to do, and to use the creation of that specification to design a nice way to interact with my code to get it to do the things that I want it to do and to see the results, leads me to a better design overall. By striving to make my own life easier, I end up with better code. My argument is that the properties that we value in high quality code, modularity, cohesion, separation of concerns, abstraction, appropriate levels of coupling, are the same properties that make code testable. So by striving for more testable code, by writing the test before we write the code and working to make it easy to write our tests, we also amplify the properties that we value in good design. Fundamentally, you can't benefit from this effect if you write the tests after you wrote the code. You're literally too late to have an impact on its design, because by the time you write the test, the design's already done. So, are there times when it's ever a good idea to write tests after you wrote the code? Well, as a strategy for development, I'm afraid I'd have to say no. It's never a better option. Writing tests afterwards has no advantage over test-driven development as an approach, except, I suppose, that it may seem easier if you want to be lazy about your testing. You don't need to think quite so hard about what to test if you're only focused on testing the implementation that you already wrote. But this is a very, very poor bet to take. It may feel simpler, but it immediately puts you on the wrong track. And that track ends up in those ugly, slow, over-complex, highly coupled tests that we saw earlier. These always end up being more work than small, simple, fast TDD style tests. The huge problem with these tests is fundamentally down to the coupling problem. It is this increase in coupling between the test and the code that we're testing that's the cause of that all too common symptom of this approach, projects grinding to a halt. The tests and the code end up being kind of welded together. They seem to set like concrete. Because these tests depend too much on the implementation detail, you can't change the implementation without making tests fail. Because the tests express how the code works rather than clearly what it's meant to do, it's harder to see what the code is meant to do. So the tests don't really document the behavior clearly. They really just say that the code is still the code that we wrote. So it's harder to add new features. This is because it's unclear how to describe them in tests. And any new feature will mean changing the implementation, and so we're back into the vicious cycle of breaking the tests again. This very tight coupling between test and code is a very, very nasty problem, and a very difficult one to unpick. So the best plan is to avoid it altogether and always start by writing the test. Although it makes no sense as a development approach, there are still times pragmatically when you may have to test afterwards, and that may be your only option. If you are in a legacy code base that wasn't written test first, then clearly this is a difficult situation, and so you may be forced into continuing writing tests after the code. I found myself in exactly this situation when joining a new team a few years ago. They had lots of test after style tests. As a result, their code worked, but was hard to work on. It also wasn't really in the right shape for test first. The code wasn't very testable. I did what I usually do. First, all of the new work that I did was written test first. So now my new code at least was in better shape. Next, I continued with the test after approach for the existing code, but also started improving the measurement points, adding some dependency injection and so on, to make the existing code an easier place to work. Over time, you can gradually start reshaping your software this way. I think that this is a better than some big bang rewrite from scratch strategy, particularly in this kind of case, because this is a complex move to make. The coupling between the tests and the code make it complex. Each change that you want to make is going to invalidate some of these nasty implementation-focused tests that don't very clearly specify what we want the code to do. So you need to understand the code and the tests very well to make these kinds of changes. The horrible problem with this coupling is that at the very time when you want to be able to rely on the defense of your system that these tests are meant to supply, the tests stop working. That's very ugly. The other place where you will need to add tests after the code is written is for true legacy code, where there are no automated tests at all. I generally start this process with bigger, more complex acceptance tests, evaluating larger bits of the system in crude, high value use cases. Starting with the high value use cases, and then start looking at what presumably is manual testing is done to support the release of the software, and then automate that too. Tactically, I supplement these tests with approval tests to support refactoring. Again, I generally start practicing true TDD for any new code straight away, and then do all of these other tests in parallel with that. But this strategy will often lead you to wanting to retrofit some more focused defensive unit style tests. And this is where you may need to add some tests after the code as a tactical hack. This is incredibly tactical, and you need to be very cautious about not falling into the overcoupled trap that I've just described. I think that the bigger picture black box acceptance tests are generally a better bet for this kind of defensive approach. And you add smaller, more coupled unit tests only for specific targeted pieces of code and to address specific problems in those bits of code. I don't think that these sorts of tests form a sensible default strategy at all in any circumstance. Even for backfilling tests like this in legacy code systems, I may pick to use these sorts of tests if there are barriers to getting the acceptance tests in place, maybe as a stopgap while trying to automate the deployment or improve the configuration management, for example. On the whole, as I suppose you can tell from this video, I really don't like unit tests written after the code at all. I think they lead us to some fairly nasty places, even though they may give us some temporary false confidence early in the life of a project. Test-driven development is a very different thing indeed, and always to be preferred in my opinion. Thank you very much for watching, and if you enjoyed our content here today, don't forget to hit like and subscribe, but also you might consider supporting our work on this channel. Go along to our Patreon community and look at some of the great things that are on offer there. Thank you.